Hello, ladies and gentlemen. Welcome back. We are on Unit 6, Lesson number 1. All right, so ladies and gentlemen, we're going to be looking at the exponential function a little bit closer today, and we're going to be dealing with money, okay, real life situations. So, saving money. Suppose you deposit $5,000 into an account that earns 4.9% annually. Always change the percent to a decimal. All right, so that 4.9%, we need to rewrite that. And remember, to write it as a decimal, you can go ahead, if you can't do it in your head, you take that decimal or that percent and you divide it by 100, ladies and gentlemen, okay, because it's out of 100, so the decimal is 0.049. All right, so this is going to be 0.049. Now, we're going to write a recursive routine or the equation for this in y equals a times b to the x power form. Now, the a, ladies and gentlemen, that's the amount you are starting with. So the a is the $5,000. Now, the b, I'm going to go into a little explanation for this here on another page. Now, remember, you are earning 4.9%. That means they are paying you money. Okay, they are paying you money. Now, if you take 100% of your money, let's say you have $100, you earn 4.9% on it annually. That means you're going to get that much money. They're going to pay you that much money. So you're going to add that 4.9% to the 100%, which is your money. Okay, that's representing your money, right? So at the end of the year, you have 104.9% of the money. That means you have more than you started with, right? Now, the decimal for 100%, ladies and gentlemen, is a 1. And the decimal for the 4.9% is the 0.049. So, let's go back. The b, ladies and gentlemen, is 1 plus the 0.049. So you understand where that 1 came from, okay? So again, it comes from that. Okay, rewatch that if you didn't quite get it. Now, I can simplify that and just put 1.049 if I wish, because when I add them together, that's what I get. Now, my equation for this situation then is 5,000 times 1.049 to the x power. Okay, pretty straightforward. All right, now what we're going to do is we're going to use our calculator here, ladies and gentlemen, and we're going to, first of all, is it an exponential growth model or a decay model? Okay, growth model, decay model. Well, think about it. You're getting more money. It's going to be a growth model. Okay, it's going to be a growth model. But why is it going to be a growth model? Well, the reason it's going to be a growth model is because the b part is greater than 1. Anytime that number in the parentheses is greater than 1, it's going to be a growth model because you are gaining money, right? Okay, now we're going to use the calculator to fill in the table of values and then sketch the graph. All right, so what we're going to end up doing here, ladies and gentlemen, is typing in that problem into our calculator. So we're going to go to our y equals. We're going to put our 5,000 in, parentheses, 1.049, close it. Remember, your exponent button is under the clear button, and then put the x. Now, second graph is the table, and we're going to start right here at 0 years. So x represents the years. So When you first start, you're at the $5,000. Okay, now 1 year later, ladies and gentlemen, you're at $5,245. 2 years later, again, annually means they're only paying you once a year. At the end of the year, they're going to pay you. So you got to leave the money in there the whole time, not take anything out. 2 years, you're going to have 5,502. So what I'm going to do, ladies and gentlemen, is I'm going to put this on over here, and I'm going to fill in this table. So 1 year, you're going to have $5,245. Okay, after 2 years, you're going to have $5,502. 3 years. Okay, now we're going to get into, let me show you here. Let me bring this back over here, folks. So let me go down to 3 years, and I'm going to go over. So see how I went over and now I'm on top of the $5,771? Well, how many cents is that? You got to look at the bottom and use your rounding rules. So $5,771.60. Okay, it is important to have the exact amount here. $5,771.60. All right, I'm going to pause this video and I'm going to fill in the rest of the table and hopefully yours will match. All right, I'll be right back. All right, ladies and gentlemen, so I filled in the rest of the table. Now, please make note when you get further down, I skip numbers, so I jumped to 10 years, okay, then 20, then 30. Wow, that's pretty good, okay? In 30 years, if you can manage to put that money away and not spend it, in 30 years, you're going to have $21,074. Now, as far as the graph goes, because this is a growth model, folks, and this is exponential, okay, you should remember from intermediate algebra or algebra 1 that it curves up. So all we're going to do for a sketch, ladies and gentlemen, is we're just going to go ahead and mark. We're going to say this is our y-intercept, which is the $5,000, because that's what you're starting with at 0 years. And all we're going to do, ladies and gentlemen, is just curve it up. Okay, we don't care about anything else. We just need to know that exponential growth is going to curve up, and that $5,000 is the initial amount. All right, let's keep going here, ladies and gentlemen. Let's look at the next one. All right, medicine. To treat some forms of cancer, doctors use radioactive iodine. It's called iodine-131. The amount a patient receives is usually 20 millicuries. That's the measurement they use. That decreases, it decreases each day by 8% in the human body. Let's make a table of values to see how much is left in the human body after each day. Again, always change your percent to a decimal, and again, if you have a hard time with that, then we can again use our calculator, and we're going to go ahead and take the 8 and divide it by 100 to get our decimal, if you can't do it in your head, which is 0.08. Okay, now notice the key word decreases, ladies and gentlemen. So, well, first of all, we're going to start with 20 millicuries of medicine. So we're going to put a 20 for A. That's our starting amount. Now, B, so in this situation, ladies and gentlemen, it is decreasing, or decreases, right? So you're starting off with 100% of your medicine, and then it decreases, which means subtract, which it's going down by 8%, right? Okay, well, if you do that, that's 92%. And the decimal for 92%, ladies and gentlemen, is 0.92. Okay, now remember, the decimal for 100% is 1 minus, and the decimal for 8% is 0.08. So technically, ladies and gentlemen, 1 minus 0.08 is the point, whoops, too many points there, is the 0.92. All right, so you understand where this is coming from. So here I'm going to go ahead and I'm going to put 1 minus 0.08, which is 0.92. All right, so what's my equation? My equation is y equals 20 times 0.92 to the x power. Now, ladies and gentlemen, this next question should be obvious. Okay, this is going to be an exponential decay because it's going down. And the reason is because b is less than 1. This number right here, ladies and gentlemen, okay, the rate, the amount we're multiplying by, is less than 1. Okay, and that's always going to lead to an exponential decay. Now, I'm going to fill in this table. So what I'm going to do is I'm going to bring in the calculator, and I'm going to type that into my y equals. Okay, so I'm going to go ahead and put my 20 times the 0.92 to the x power. All right, and then I'm going to go to my table, and well, I'm going to need to go all the way back to 0. Okay, a little trick here, or you can just scroll there. And I'm going to fill in the table. All right, so I'm going to pause again. So you could pause, type that into your calculator, and fill in the table. I'll be right back. All right, ladies and gentlemen, I filled in the table. Okay, looks pretty good. Hopefully your table matches. Now, I'm going to make a sketch of this, ladies and gentlemen. So what I'm going to do is say, okay, so this one's going to curve. Think about it. Exponential decay is going to curve down. So I'm going to go up a little bit higher, and I'm going to say that this is 20. So that's when you first take the medicine. Now, curving down needs to look like this, okay? It needs to go like this, because eventually it's going to level off right around the 0, because eventually it is going to disappear and be completely out of your body, all right? So it curves down like that. Now, make sure it's curving down. You're going, well, how else can you? I've seen some strange curves before, ladies and gentlemen, so I'm just warning you. Make sure it looks like that, okay? Because this is what I've seen in the past. I've seen people do this, and this is totally wrong. I've seen things like this. No, that is totally wrong. It's got to curve down so it flattens out at the end, okay? All right, ladies and gentlemen, let's see. Okay, that was it for that problem. Okay, I think I've got one more. Nope, that was it, ladies and gentlemen. That was the whole lesson. So we've got an example of exponential growth, and we've got an example of exponential decay. Pretty straightforward. All right, if you need to, rewatch any part of that. Otherwise, I will see you soon.